narrow presentation from the stuff we're into at HeartMath related to the global coherence initiative work. I think I spoke, was it 3 years ago? Was it 3 years ago we were in Boulder? Anyway, about, some of our collaborators on this particular work, Mike Atkinson, who's our lab manager at the Institute of HeartMath, Heather Connery, Dr. Abdullah Al-Gadr, who's head of a cardiac hospital in Saudi Arabia, and York, which we all know from here, is one of our collaborators on this as well, and been helping us with a lot of the analysis. Just kind of a high-level background of what this project is about. Our kind of guiding hypotheses are, first of all, that human and animal health, our cognitive functions, mental capacities, and so on, emotionality, and behaviors are affected by different changes in the planetary, magnetic, and energetic fields. Not so sure that's really a hypothesis. That's quite well established, actually. And number two, the Earth's magnetic fields act as carriers of biologically relevant information that interconnects all living systems, kind of interconnects the ecosystem. And thus we're all coupled to and affect the system of the global field environment. Some support for that, I've shown this before, but I think it's a rather profound set of data. This was from Alexander Chesovsky, a fairly famous Russian astrophysicist who after World War I noticed that, well, during World War I, when he was drafted into the war, that it seemed that during high solar activity that people just did more stupid things, basically. So after that, he did an exhaustive study of human history. Quite impressive, actually, what these guys did before we had internets, right? In fact, he was offered a Nobel Prize for this work, but it was not, couldn't get out of Siberia to do it. But anyway, long story short, we start at 1749 on the left side of the top graph in blue and then wrap around to 1926 when this was published. What's being plotted or shown in the blue is just a dot for each year, the number of major human events that occurred, globally important major human events is what's being plotted there from 1749 to 1926. Okay, revolution, start of a war, big major things, new discoveries, global impact type things. The red line on the bottom is the solar cycle during the same period. Okay, so I think we have and this has been, of course, confirmed and extended into modern times by many different authors, and is a very real, very strong kind of relationship. So since then, this is just a very brief summary. A lot of different studies, hundreds actually, have shown that there are many correlations, some are actually that are looking at causality as well involved in it, between changes in the rhythms and the frequencies in the Earth's magnetic field. Things like our brain and nervous system activity, EEG measures, these kinds of things. Performance of tasks. It's everything from bowling scores to psi studies or remote viewing studies have all been shown to be less effective when basically the Earth's field is disturbed or we perform less well. Blood pressure, heart rate, hormones. Dr. Franz Hallberg's done a lot on this, the guy who coined the term circadian rhythm. In fact, our heart rate and blood pressure rhythms can actually literally synchronize to some of the rhythms in the planetary fields at certain times, certain cases. Number of traffic violations, number of tickets that are written by cops, the number of actually accidents that happen all kind of ride this same frequency and rhythm. Hospital admissions, a lot of work's been done on this. It's not just heart disease and strokes, it's quite a wide range of health issues. In fact, just heart attack admissions to hospitals, at least in North America, increased by about 8% during magnetic field storm. Disturbances in the magnetic field. It's quite a bit. 8% is not a trivial number, right? Okay, anyway, criminal activity. The bottom comment there, this is actually from Dr. Hallberg's work. I originally found that of all these things we can measure physiologically, the most sensitive that appears to reflecting, at least human responses to these changing magnetic fields is actually heart rate variability. I'll explain a little bit more about if you don't know what that is in a second. So if we're going to do science around this, the science of interconnectivity, we've got to measure things, obviously. So we're measuring the Earth's magnetic fields. And to do that, we're installing what we call the Global Coherence Monitoring System. And unfortunately, we have to do this ourselves because the NOAA and the other type magnetometers are out there do not measure the things that we think are important. They're currently out of this global map, but we would like to see there are 5 current monitoring systems installed here in California, about an hour and a half south of here, actually, in the Boulder Creek area at our facility. Canada, Lithuania, Saudi Arabia, and New Zealand are the ones that are installed and currently operating, and hopefully we'll fill the map out a bit more. So what the site looks like in Boulder Creek. And the magnetometers themselves, these are extremely sensitive magnetometers. They're about the most sensitive we can find. They're three axis, north, south, east, west, and vertical. Very long, devices. They're buried about 1 meter underground. It's the one in Saudi Arabia. These projectors don't do very well. And there's Dr. Abdullah, our partner there. So what are we measuring anyway? And why do we have to create our own systems to do this, these GPS time-locked systems? So when we look at the geomagnetic field, that's a static or a stationary field, right? I mean, it's, in terms of our day-to-day lives, it really isn't changing. It is, reported to be decreasing in magnitude by about 15% over the last 200 years. But for our day-to-day lives, it's really pretty stationary. So what is relevant, though, of the geomagnetic field, of course, that's what our compasses tune into, right? Is that if you think of these flux lines, and they really are flux lines, and they got high-energy particles spinning them around them and all these things, like guitar strings, right? And when you pluck a guitar string, obviously it vibrates, right? And depending upon the tension of the string, it vibrates at a different frequency. So what's plucking the strings of Earth's geomagnetic field is the solar wind. Now, the solar wind, on average, travels about 1 million miles per hour. During a coronal mass ejection or a solar flare, it can actually jump up to about 5 million miles per hour. Pretty dramatic changes. So again, here the Earth is turning, right? And the solar wind, which is a strong enough pressure, it pushes in the magnetic field on the daytime side and stretches out the tail. Nighttime, I mean, this is all basic high school stuff, but what we didn't learn, at least I didn't learn back then, is that the solar wind is plucking the strings of the Earth's magnetic field. And the technical term is called structural field line resonances for that. And when we measure them, this is what the frequency range they tend to be in. And they're fairly strong in terms of magnetic field strength. They're quite strong. They're much stronger than the Schumann resonances, which we'll talk about in a second. And so one of the common modes we see here is around 0.1 hertz, 10-second rhythm. As it turns out, that's exactly the same rhythm as the resonant frequency of the human cardiovascular system. So like in my other presentations, I talked about heart coherence and all that. That is exactly a 0.1 hertz rhythm. So Earth is basically vibrating away at the same resonant frequency as our core resonant cardiovascular system frequency. All of these frequencies in this range overlap human and animal cardiovascular system frequencies and rhythms. Okay. Then we also have the Schumann resonances, which most of you here are probably familiar with. 8 primary Schumann frequencies. And these are any magnetic wave that gets created that's resonant with the earth-ionospheric chamber. And when we measure those, 7.8 hertz is the fundamental one. And we can say it's 7.82, but in reality, there's a half hertz variation every day, so it's around that. All of these overlap human brainwave rhythms and frequencies as well, right? Which is why we think this is important. We've got 2 different resonant frequencies occurring consistently in the Earth's field environment that overlap us, our core biological rhythms. So the magnetometers that NOAA and different ones have around, report KP and all that, they don't measure this stuff. They don't see it. Right? So I wish we didn't have to do this ourselves. So our perspective is that the interface that explains so many of those other studies I kind of summarized at the beginning is because we are resonant with these frequencies, and that the nervous system actually is the interface. Like Friedman, you kind of alluded to that as well, which I tend to agree with. This is what some of the rhythms look like. Well, this projector is not very good. A lot of work got done on Schumann resonances and ionospheric modeling and all this back in between 1960 and 70. So the Schumann resonances weren't first experimentally measured until about 1960. And there was a lot of funding for 10 years, and then boom, it dried up, nothing since. Right, and one of we have a lot better equipment now than they had in 1960, obviously, right? But one of the perspectives back then was that if you have one of these magnetic monitoring sites, it's going to be the same everywhere. It's a global wave, right? So you got one site, same everywhere. Well, I don't think so. This is looking here at here in California, New Zealand, and Canada. Pretty obviously different signals from those different sites. There is a global coherence, if you will, but significant local differences. In fact, what we see from the other study I'm not going to talk about today, but is that the populations that we look at around a certain local site, we get significant correlations, but not to the other sites. So these local differences are clearly important in terms of how they affect us and humanity. All right, this is just another look. These are Freeman also referred to PC1s. This is what they actually look like. So this is a low frequency rhythm with a period of about 1.5 seconds. They're pretty fast rhythms, but still not what I would call ultra low, but very low rhythms. And then we have lower of the PCs that go on down. Now here's a bit of a mystery to me. I hope you can see these. We have always observed these very rapid, high magnitude pulses in the data. These are like less than 1/4 second wide. They're really fast. So when you only have one site, you can kind of go, okay, this might be some noisy source, an airplane flew over or something that we really don't know. Now that we have time-linked multiple sites around the planet, lo and behold, these things are global, and they're exactly in time. Right? It's not like you have a wave going around the planet where you would expect slight delays that you can measure. They're exact, and they're global. So the local noise hypothesis is out the window. Hopefully somebody in this room can tell me what these are. I don't know. I really don't know. And I've done a lot of searching in the literature, and I've asked a lot of people about this that are supposedly experts. In fact, just a fun story, true story. I tracked down the person at NOAA in Boulder, Colorado, who monitors the data that calculates KP, what's called KP index and all that, who confirmed, oh yeah, we see these. And I literally talked to the person, to the lady, whose full-time job is removing these from the data. Absolute true story. If we don't know what they are, we gotta, I swear to God, we are paying for have this removed from the data. I suspect they're important. The fact that they're global, it's really interesting. So I'm serious. If anybody of you in here might know what these things are, the real source, or know somebody who might know, I'd love to talk to you. Okay, so the study I wanted to tell you about today that's kind of got our attention. We have a couple different projects going on that are very similar to this. But this one, I want to share the data with you today, some of the data, but it's from 10 people, working adults, mean age was 53. We basically have these little recorders that record heart rate variability, kind of lightweight little things, you forget you've got them on, that allow us to do long-term recording. So we're doing 24-hour-a-day recording for 30 consecutive days. So we have a continuous HRV record for 30 days from 10 people. It's pretty unique data. And like Dr. Hallberg's studies I mentioned, his longest studies were like a week, with very small groups of people. Another data set that York's been working with us on is 5 months worth of data. But so we're looking at the correlations, if you will, between the HRV and the solar geomagnetic measures. So I don't have time to go through all these. KP index, if you're not familiar, that's what the space agency NOAA reports as a measure of magnetic field disturbance. It's basically the ripple on the DC. Think of it that way. We get hit with a solar flare and coronal mass ejection. It causes more ripple, and that's what KP measures. F10.7 is a measure of solar radial flux. I'll talk a bit more about that one in a second. Solar wind speed is one of the ones I'm going to talk about. And the GCI magnetometers. Okay, 5 minutes, I'm probably good. So that's basically the time-varying magnetic field. It includes the Schumann resonances, and all the other stuff in between there. That enough to say there. Okay, heart rate variability, for those of you who aren't familiar with it, it is basically a measure, a non-invasive measure that allows us to measure autonomic nervous system function. Okay, so it's kind of produced by the activity in the autonomic nervous system, sympathetic, parasympathetic, and all that. It's a fairly robust measure. Again, just due to time, these are the HRV measures we're using for the study. These are, these are 24 hours a day for a month, so we're using the averages of 5-minute segments of the HRV, then we average those to hourly measures, because that's what most of our environmental measures are. Okay, so these different HRV things measure different aspects of nervous system activity, parasympathetic or sympathetic or these kinds of things. Okay, so the way the data I'm going to show you was done, so the time series across the 30 days was all synchronized. So all of our subjects are synced in time, so we know everybody's lined up well. Then each of our subjects' data was normalized, okay, to have a mean of 0, and then a plus minus, then a range that varied between plus and minus 1. Then we averaged all the data together for 9, in this case 9 subjects. And so circadian rhythms were removed, and so on. Now, here's what is really surprising. Okay, so this is 9 people's 24-hour-a-day HRV data, and they live within about a 50-mile radius. One of the subjects was actually in Southern California, right? So what we're seeing here is synchronized activity across our 9 subjects. We should not be seeing this. This should be kind of noise. Not only are we seeing synchronized activity, it's got around a 2.3-day rhythm. This implies they must all be synchronizing to some environmental something or other. Right? This was totally unexpected. We did not expect to see this. Now, something over here disturbed it. Then it sort of came back over here towards the end of the 30 days. Well, lo and behold, what it is, across the 30-day period, that HRV data is significantly correlated to the time-varying magnetic field, which has the same rhythm, but got disturbed right in here. And so you see the rhythm get disturbed, that 2.5-day rhythm. The magnetic field get disturbed, and then it kind of settles out and starts coming back, and then we see the HRV resynchronizing. So it turns out, right about here was a solar flare, a coronal mass ejection. And one of the measures of that is what's called the F10.7, which is a measure of it's basically a 2.8 gigahertz radio wave frequency the sun emits. Okay, I'm going to have to go a minute over, so I'm sorry. And that's preceding this increase in HRV. And it's a positive correlation, which in another study we did a couple of years ago, we found when F10.7 increases, people feel better. They're more cognitively clear, less mental confusion and all that. So lo and behold, and the F10.7's light is speed of light. It gets here in 8 minutes after a solar flare. Right? The plasma, the solar wind stuff, it takes a few days. And here's the solar wind speed, now that we add that, showing up a couple days later. Okay? What a beautiful kind of, I wish we could have, I was as good as predicting the results as what we actually find sometimes. You know, I could have never have guessed that we would be seeing this kind of correlation. So long as I'm out of time, but basically what my summary would be is that we are far more interconnected with the Earth's field environment and the magnetic fields than we even thought or would have projected. So it's a far more interconnected world than what we might have previously conceived of. Anyway, we have some cool new studies that this is going to generate, I think, some new things we'll do.
Thank you, Rollin. I guess we have time for questions. Garrett, okay.
If that strange magnetic pulse is genuinely simultaneous everywhere, there's only one choice in terms of its origin, it seems, and that would be from the center of the Earth. And so it seems like it may be a good way to study what's happening at the Earth's center. Is that being investigated?
Well, I don't know that anybody, I mean, NOAA's getting rid of the data, right? We have the only system I know of other than quake finders who could care less about this kind of stuff probably. I actually agree with you. I just didn't want to go there, but I mean, I do go there. The only possible source is center of the Earth to come out like this, I agree. What the source of that is, there's still got to be a mechanism somewhere that's creating these pulses. And they're pretty regular. And we're actually creating some algorithms right now. We have massive amounts of data from all these sites coming in 3 axes. So it's not, you can't sit there and go through this stuff by hand. So we're creating in MATLAB some wavelet routines to identify these pulses so we can start looking. It actually looks like they have their own rhythm, so to speak. But maybe next year or we'll be able to report on the pulses. But, yeah.
Did I understand you correctly to say that when you get a CME, then it generates peace and well-being? Mm-hmm. Then how
before the plasma wave hits.
Right, but then how does that relate, or does it relate then to your first slide that did this historical information that seemed to say that when there was a lot of solar activity, we all did stupid things?
Yeah, yeah. I had to truncate so much of what I would like to have said because it actually is true. What Chesovsky's data showed and has been verified. However, what I need to add to it, the greatest periods in human flourishing also correlate with those same periods. Okay, so in other words, it's an energetic influx, right? That comes in wherever it comes from, cosmic, solar sources. Yeah, and yeah, it's stupid and smart at the same time. It really gets down to how self-regulated are we? How do we use that energy? We can either use it to create new collaborations, solve problems, or we can use it to go start squabbles. And you know, I actually gave a longer presentation of this in Saudi Arabia a while back, and one of the guys raised his hands. Can't we just lock up all the politicians for that 2-year period around that? Yeah, actually.
Just quick comment. There's another time synchronized event that Simon Schnoll, a Russian researcher, showed that in radioactivities and enzymatic reactions, chemical reactions, there's a periodic thing that occurs and repeats. Normally when you look at data, there's scatters of data, and the scatter of data is reproducible anywhere in the world if the experiments are done at the same time. And like radioactivity even, the scatter is not random. And it has a periodic occurrence of about 24 hours and about a month and about a year. And he's done about 40 years of research. And when I look at your data, I'm just wondering, is there any correlation with regard to that? But it's just an observation that Simon Schnoll's work has this periodic thing associated worldwide.
Interesting. Who's the? I'm not. I'd love. Maybe we can talk offline.
Yeah, we'll talk afterwards. But
yeah, who's the researcher though?
Simon Schnoll.
Oh, Schnoll's work. Yeah. Actually, Dean turned me on to him. Yeah, it's I think related but different.
Different,
in a way.
but
yeah.
Is there some commonality? That's
right. Yeah, the other data set that York's been working with on it has a whole other kind of neat picture that adds to this, but cosmic rays and different things too. But that's
okay. Right, I think it's time to get on to the next presentation.
Sounds good. Thanks.